Hello dears, we are studying strength of material and today's topic is type of stress. So for a study the type of stress, first we see the axis. So for this we draw a body and this body has three axes, 1, 2 and 3 axis. So this one x axis, this one is y axis and this one is z axis. So along x-axis it is called longitudinal axis and remaining two axes which is perpendicular to the longitudinal axis is called lateral or transverse axis. The remaining two axes which is perpendicular to the longitudinal axis is called lateral or transverse axis. And what is longitudinal axis? So longitudinal axis is the axis that which body is longest along, or we can define it, the body is longest along which axis is called longitudinal axis. This one, and the remaining two perpendicular axis is called, and the remaining two perpendicular that axis and the remaining two perpendicular axis is called lateral axis or transverse axis. Lateral axis or transverse axis. Now we will see a type of stress. So here two type of stress. First one is normal stress and second one tangential stress or shear stress. Both are same. So in today we will study about the normal stress. What is normal stress and its detailed explanation today we will see. So what is normal stress? Normal stress, the stress which act on normal to the plane is called normal stress. The stress which act normal to the plane is called normal stress. For this normal stress we draw a body. This is a body and this is the axis of body, that is longitudinal axis, and this one is the plane of body, that is plane, and that plane which is normal to the stress, that is normal stress, which is normal to the plane, the stress which is normal to the plane. So here you can see this stress is normal to the plane, that is perpendicular, or can say perpendicular, and this is oblique angle. This is perpendicular to the plane and theta is the oblique angle called obliquity. And that plane is called oblique plane. That plane is called oblique plane or oblique section. Here normal stress is a type of longitudinal stress. Normal stress is a type of longitudinal stress. How it is a type of longitudinal stress? So for this again we draw a body. Again we draw the body here the body, and here draw a plane. Plane is perpendicular to the normal stress. Here plane is perpendicular to the longitudinal axis. So here plane is perpendicular to the longitudinal axis. This is perpendicular to longitudinal axis. This one is longitudinal axis and this one is axis is plane. Here normal stress is acting which is perpendicular to the plane. Here theta equals to 90 degree, and this plane, if the plane is perpendicular to the longitudinal axis, if the plane, that plane you can see, and this is perpendicular to the longitudinal axis, and or we can say normal stress. So if the plane is perpendicular to the longitudinal axis, that plane is called cross section. That plane is called cross section, or we can say cross plane also. So if the plane is perpendicular to the longitudinal axis, the plane is called cross section, and area along that section, that plane is cross section, and area along the section, that is area which is along the plane. So area along that plane or that section, we can say cross section area, that is cross section area, and area along that section is called cross section area, and area along that section is called cross section area. That area is cross section area. Here normal stress, that is cross section area. Now here the cross section area is along the plane, cross section plane, and normal stress is collinear along the longitudinal axis. Here normal stress is collinear along the longitudinal axis of the body. Axis along the body. Here it is the longitudinal axis and this is normal stress. So both are, you can see in body, both are collinear. That is longitudinal and normal stress. So both are collinear. Longitudinal axis and normal stress are collinear. And a stress which is acting along the longitudinal axis is called longitudinal stress. So we can say the normal stress is a type of longitudinal stress. A normal stress which is acting along the longitudinal axis is called longitudinal stress. That is the same. First one is longitudinal axis and which acting the normal stress which is acting longitudinal stress is called longitudinal stress. These are two types. Longitudinal stress has two types. First is tensile stress and second is compressive stress. So what is tensile stress? If the force acting on the body, if the force acting along the body, or we can say if the force acting along longitudinal axis, if the force acting along longitudinal axis is tensile in nature, that is extension in the body takes place. So if the force acting along longitudinal axis is tensile in nature, then the stress is produced is called tensile stress. Now in case of compressive stress, if the force acting along longitudinal axis is compressive in nature, in compressive stress it will be the force acting is compressive in nature, then it is called compressive stress. And sign convention, so sign convention for tensile stress is positive. Sign convention for tensile stress is positive and sign convention for compressive stress is negative. Sign convention for compressive stress is negative. So these are tensile stress and compressive stress. Now we will see about the equation of normal stress. What is the equation of normal stress? So for this, again we draw a body. This one is body and here plane. This one is a plane xx and at which normal stress is acting sigma n. This one is xx plane is called oblique plane and here tensile force, we can say tensile force or uniaxial loading, because force is acting along one axis only, so it is called uniaxial loading. So uniaxial loading is applied on body. When this load is applied on body to normal to the, then its plane angle make the theta. This angle will be theta, that is obliquity. So this load make an angle theta with the oblique plane. Therefore along the oblique plane the force will be p cos theta and the, we can say, load will be p cos theta, and along the normal stress the load will be p sin theta, which is perpendicular to the plane. You can see it is perpendicular to the plane, which is normal stress, and that one is area of cross section of body. Area of cross section of body. Now we make an triangle. So now we will separate this triangle to understand. This is area A and here we separate the triangle. So this one area A, obliquity theta, and this one is a plane which is acting normal stress perpendicular to the plane. So here sin theta will be A by A dash, or A dash is equals to A by sin theta. So area of A dash is equals to A by sin theta, which is oblique plane, and here normal stress is perpendicular to the oblique plane. So here normal stress acting on the oblique plane, then normal stress sigma n is equals to, that is p sin theta along the normal stress. So p sin theta by area is equals to plane of area, so A dash. Sigma n equals to p sin theta by A dash. Now we will put the value of A dash, so sigma n is equals to p sin theta by A by sin theta. Therefore sigma n is equals to, when sin theta go to up, then sigma n is equals to p by A sin square theta. So this is the equation for normal stress, that is sigma n equals to p by A sin square theta. So these are all about type of stress in which we study about normal stress or what is normal stress and this equation. So thank for watching.